Alright guys, so today we are talking about section 3.6. This is going to be all about graphing quadratic inequalities in two variables. We also are going to be looking at how to solve a quadratic inequality in one variable. To graph a quadratic inequality in one of the following forms. Here's our steps. Graph the parabola with this equation. If we have less than or greater than, we use dashed lines. If we have less than or equal to or greater than or equal to, we use solid values, curves. We're going to test a point inside the parabola. You can do it this way, but I'm going to show you an easier way. Shade the region inside if the point from step 2 is a solution. And again, I'm going to show you another way. Alright, so if I'm trying to do this problem, I want to graph this. Let's see where the vertex is. Vertex is at 2, 3. I want to make sure I can plot that. This is fine. So over 2, up 3, there's our vertex. This is -1, so that means I'm going to open down. I might want to just go ahead and find if x is 0. If I plug in 0 for x, I'm going to have -2 squared, that's 4, -4 plus 3 is -1. So if I know that point, then I also know this point because of the symmetry. This is greater than or equal to, so I'm going to use a solid value. If you want to be real exact, you could plug in 1. 1 minus 2 squared is -1 squared is 1, so -1 plus 3. At 1 we're going to be at 2, so we also know that point. And then we're going to use solid. Now, they tell us to test a point. That's all well and good, but here's the thing. This is saying, where are the y values that are greater than the parabola? Well, aren't the y values that are greater than the parabola just out here? If you wanted to test a point, you could test 0, 2 and see if it works. If I plug in 0, 2, I'm going to plug in 2 for y. I'm going to plug in 0 for x. 2, is that greater than or equal to? -2 squared is 4. -4 plus 3 is -1. Is that true? Yes, it is. So wherever 0, 2 is, you want to shade there. Okay, that's the way they tell you to do it. I just tell you, graph the y's that are greater than the parabola. Now, this is pretty awesome. You can do this on your calculator. So with the new calculators, what you do is you put in -x minus 2 squared plus 3. Then you go over here, okay, and you're going to hit enter on this, and you are going to say that you want it to be, toggle through this until you get to greater than or equal to, okay? Now this is asking you for the style. That just means whether it's going to be like solid or whatever. I'm going to do OK. So watch what it does now when I hit graph. I should have done a zoom 6, darn it. That's okay. But you can see how it's going to look now. It graphs that for us. Let me do a zoom 6 just so you can see that vertex at the 2, 3 like it should be. Okay? So that's a pretty nice feature. The older calculators are a little bit different on that. I'll grab one of those. So on the older calculators, if you have one of the 83s or something, go like this. You can still do it. Go to y equals, turn off your stat plot. Ooh, that's dark. I can lighten the screen by going second down. It's not easy to see, is it? Alright, well, let's see if I can get this. Okay, that's a little better. Alright, so I can go down here and I can put in -x minus 2 squared plus 3. Okay, now this is where it's kind of weird. I have to go all the way over here, and for this one, if I have a triangle that's low, like watch, if I push enter, that is just a solid line. That's not what I want. This little triangle means it's going to shade less than. That actually means less than. Hit it one more time. That's a weird thing. You don't need it. Where is it? I want a greater than. There it is. So this is the greater than. That's the symbol for greater than. And so now if you graph it with a zoom 6, you'll see it. A little bit different with this one, but can still be done. All right. Let's go over here now. And exercises 1 through 4, match the graph with its inequality. Well, think about the easiest way to do this. One way would be to look at whether it's solid or dotted. This is dotted, so I know it has to be either this one or this one. Yeah, this is going to have to be one of these two. So now I'm going to say, well, same thing here. This one's dotted. It has to be one of these two. This one is saying the y values are going to be shaded that are below the parabola. So the ones that are below the parabola is going to have to be this one. So this has to be A. This one is also dotted, so we know it's going to have to be this one, but let's talk about y. So here's the parabola dotted, and then it's going to have to be the y values above it, so that's going to be C. This one is opening down, so I know it's one of these two, but it's the y values that are greater than, so it's going to be the one above it, so it's going to be D. And this one is the one below it, so it's going to have to be B. That should go pretty quick for you. All right, graph the inequality. Okay, we may not have to do all of these. I'm just going to do maybe a couple. We'll do this one and this one. All right, so if I'm graphing this one, the real quick way to graph it, I know it's a parabola that's been shifted up 2 units. I know I'm going to use a dotted line. If I plug in 1, I get 3. If I plug in 2, I'm going to get 6. Just getting a couple points. I'm going to do a dotted line because it's less than. And then if I want the y values less than it, that's down here. Looks just like that. Maybe should shade it a little nicer. Okay, on this one, I can see the vertex immediately. This one, the vertex is going to be at -4, -1. Okay, so I'm going to have this point as my vertex. I know it's going to open down. Maybe you want to test a point. Let's plug in 2 just to see. 2 plus 4 is going to be 6 squared. Is going to be -30. Ooh, that's going to be way down there. Okay, so let's just check this point then. So if I'm sorry, I plugged in, what did I plug in? I meant to plug in -2. Let me plug in -2 again. -2 plus 4 is 2, squared is 4, -4 minus 1 is -5. Sorry about that. And so then I know I also have this point. Going to make it solid. Okay. And then I want to shade all the y's that are above it. So that's going to be up here. All the y's that are above it. Okay. So again, I'm not going to do these. To graph this one, you would just want to find the vertex using our -b/2a, or you could complete the square, whichever you prefer. All right, number 9. Accident investigators use the formula D equals 0.01875 v squared, where d is the braking distance of a car in feet and v is the speed of the car in miles per hour, to determine how fast a car is going at the time of an accident. For what speeds would a car leave a tire mark on the road of over 1 foot? Okay, so let's go back and see. D is the braking distance, so we want to have 1 in for D. Okay, and v is the velocity, and that's what we're trying to find. So I'm going to set this up. I want this 0.01875 v squared for what speeds over 1 foot. So I want this to be over 1 foot. So this is what I would have to solve then. So I would then have to divide 1 by that. get that answer, and then I got to take the square root of that. And I get this. So it's truly that v is going to be, plus or minus that, but we can't have a negative speed, so it's just going to be positive. So for any v, velocities would have to be greater than 7.3 miles per hour. Those are going to be the values that are going to leave a tire mark of over 1 foot. Okay? All right, graphing a system of quadratic inequalities. So to graph this one, I'm going to want to graph it by finding the vertex. The vertex is going to be -4 over 2, which is -2. Plug that back in. -2 squared is 4 minus 8. 4 minus 8 is -4. So -2, -4. Plug in 0, you get 0. So I've got that point. Then I'm also going to have this point. So let's go ahead and make it solid, because it's greater than or equal to. Now, here's the thing. When you're doing a system, I don't want to start shading this. I'm just going to kind of tell myself I'm going to shade above this eventually. Now I want to graph this one. My vertex is going to be -2, -1, and maybe plug in 0. That's going to be -4 minus 1 is -5. So I'd also have this point. This one is going to be dotted instead of solid. And then for this one I have to shade below. So I have to make sure that both of these work. I have to be above this one and below this one. So all of the only regions that's going to be shaded is right there. It's kind of cool to look at this on the calculator. So I'm going to be doing, now if I want to change this, I got to hit enter. And do I still want it greater than? Yep. So that's fine. Okay. So I do still want to be greater than. And it's x squared plus 4x. Okay, here I want it to be less than, so I'm going to go ahead and put it in first. I'm going to go over here, hit enter, and I'm going to go down here, push enter, oops, up here, hitting enter. I want to hit over on that. I want to get just less than. I went too far. Just less than. There we go. Now go down and push OK. Alright, and so now I'm going to do a zoom 6 to get my standard screen. So here's the first one, and notice they're shading everything above it. Here's the second one, and they're shading everything below it. And so now I have to look for the overlap, so I can see that we did it right. Right there is the overlap for them. So that's the part that works for both of these. So any point in here would be a solution for both. All right. Last couple things here, solving this algebraically. I'm going to start off by just treating it as an equation. So I'm going to have x squared equals 100 over 16. I'm not going to simplify because it's easy now just to take the square root. And I'm going to get x equals 10 over 4, which is 5/2, and it does have to be plus or minus. Now, these are the values that are going to make these two equal. I don't want to make them equal, so I'm going to make a number line, 5/2 and -5/2. Those make it equal. So all I have to do is plug in a number. I'm going to plug in 0 back into the original. 0 squared is 0 times 16 is 0. Is 0 greater than 100? No. So therefore this part does not work. So these parts must work. It's going to have to always go every other one. This is 2.5. If you don't trust it, test 3. 3 would be down here. 3 squared is 9. 9 times 16 is 144. That is greater than 100. So this works down here. For the next part, I just tested 3 and it worked. So negative 3, that'd give me the same thing, so this works. Okay? Here's the way we're going to write this solution. In inequality form, it would be x less than negative 5 halves or x greater than 5 halves. That would be as an inequality. We're typically going to write these in interval notation. So negative infinity to negative 5 halves, union 5 halves to infinity. This is the way we're going to write it. That's inequality. This is our way. So what about one like this? Well, 3x squared minus 13x is going to have to be plus 10. First, we're just going to treat it as equal to 0. See if it can factor. I don't want to use a quadratic formula unless I have to. Are there numbers that multiply to be 30 and add to be 13? Yeah, 10 and 3. Great. So I know I want to get a 3 and 10. So I'm going to need this to be 1, this to be 10, this to be negative, this to be negative. Check it. 3x squared, negative 3x minus amp. That works. It all works. So here are my solutions then. I'm going to have 3x minus 10 is 0, or x minus 1 is 0. So here I'm going to get 3x is 10, x is 10 thirds. Here I'm going to get x equals 1. That's what makes these equal. I don't want them to be equal. So I'm going to put 10 thirds here. That's 3 1/3. 1 here. I'm going to check something. Actually, I'm going to check 0. I want to see if 0 works. 0 minus 0, is that greater than negative 10? Yep. So this region works. Plug in something down here if you want. So plug in, what's that, 3 1/3? Plug in 4. 4 squared is 12. 12 times 3 is 36. 36 minus 39. That's going to be negative 3. Is negative 3 greater than negative 10? Yes, it is. So that works. So, as an inequality, x has to be less than 1, or x has to be greater than 10 thirds. In interval notation, negative infinity to 1, union, 10 thirds to infinity. Okay? All right. Last one. The profit for a hot dog company is given by the equation y equals negative 0.02x squared plus 140x minus 2500, where x is the number of hot dogs produced and y is the profit in dollars. How many hot dogs must be produced so that the company will generate a profit of at least $150,000? All right, so we want to make at least 150. Let's see here. That's going to be our y. So I want for this, now think about it. If it says at least, does that mean I want less? No, I want at least this. So I want my profit to be greater than or equal to this, 150,000. That's what I've got to solve. Okay, so let's go ahead and subtract this over. Negative, you know what though? This would be a great time to use our calculator. I mean, you know, I can use a quadratic formula. I can use, you know, all kinds of different things, but, and I want to take this back to equals again. I'm not truly doing this part. I want to know where are they equal, and so I'm going to push enter. Whoops. Toggle through this. I want it back to equals. That's fine. Okay. So I'm putting in negative 0.02 x squared plus 140x minus 2500. Okay, and then here I'm going to put in 150,000. I don't want that. I just want it equals again. So I'm going to go over here. Go down here, toggle through, get back to equals. There we go. Okay, so the question is, where is this greater than that? I don't need to use less than or equal to figure it out. Here's what I'm doing. I have to set my window. My x is going to be the number of hot dogs. Well, I can't make a negative number, so I'm just going to make it 0. The maximum hot dogs, I have no idea. Let's go with 100 to start with. The y is the profit. They're talking about us making at least 150,000. I need my y max to be, like 200,000. 200,000. Okay, let's see what that looks like. It may not be right. We'll change it. Okay, did I put the negative in there? Oh my goodness. It's a lot more hot dogs than what I was expecting. Go back to that window. It's going to be a lot of hot dogs. Let's put in 3,000. How's that look? That's better. Okay, but I need it to be greater than, I need for my blue line to be greater than my red line. I need to go further out. This might need to be 10,000 even. This is what you got to do, guys. You just keep checking it until you get it to look right. Changing that window. There we go. So, for this many to this many hot dogs, we're going to make a profit of at least 150,000. We can't be down in this region or this region. We got to be up there. So I'm going to do second trace, calculate, intersect. I'm going to do the first one. Get close, enter, enter, enter. And so 1,349.4. Now, I'm not going to round that down, though, to 1,349, even though 0.4 typically would round that down, because I have to make at least 150,000. So I'm going to have to round that up, because if I only do 1,349 hot dogs, I'm not at 150,000. So I know that the number of hot dogs I'm going to make is going to have to be x is my number of hot dogs. I'm going to need that x value to be greater than, or it could even be equal to 1,350, 1,350. That would do it. Okay, 1,350 would do it. Let's see here. Intersect again. Oh, watch, I'm going to jump down to the red line. It's faster. It's closer. Okay. Enter, enter, enter. And 5,650.6. I got to think that through. If I round that up, I'm actually going to move below the red line. I got to stay above the red line. I got to round that down. So I have to say, or my x value has to be less than or equal to 5,650. Even though that rounds up to 51, if I go over to 51, I'm actually below. Okay. See, if I go to that 5,651, and let me show you this, watch. Second trace, calculate a value at 5,600, and I'm saying, what if we did round this up? What's our profit going to be? Oh, $149,963.98. Nope, you didn't make enough. We said you had to make at least 150,000. So nope, this number doesn't do it. But watch. If I do a value for 5,650, does that do it? Yep. You're going to make $150,050, so that's good. So this is the amount we need to make. This is it written as an inequality. This is it written in interval notation. Those are going to be the number of hot dogs. Okay? All right. That's it for inequalities.